Okay, welcome everyone to this continuation of the AI for the working mathematician. Yeah, today I would like to talk about reading with AI, which is literally what it is designed for, essentially. So if you are still skeptical that AI is really useful for you, for reading it's really good. I will explain it to you today, right? Because it's like what it's built for. Yeah, we'll see what that means. So in this case, it's like super useful. So strongly recommended to use it. Keeping in mind that you still need to double check everything, right? It's not perfect, so don't rely on it too much. It's this idea of this unreliable co-author that you might have. So the whole starting point, I think, is one of the big problems of modern science, if you want to call it a problem, that the number of papers grows very fast. So here I found this data here from the World Bank. Here's the number of papers, essentially, scientific and technical journal articles. This is not the number of math papers. I don't have a good statistic on the number of math papers published per year, but you can literally see what's going on. We can try to zoom in a little bit, actually. So here, yeah, a lot of papers. And you can literally see this nice curve. So there are 1 million somewhere here, then we have 2 million here, and we're like 3 million. A lot of papers, yeah. So there are more and more papers published every year. So essentially, knowledge grows exponentially. Yeah. The 5 million, well over 5 million. I guess we had 3 million, whatever. A certain million number of articles are actually published worldwide, and it keeps on growing. So in science, if you're a working scientist, researcher, whatever, you'll see that if you grow up in whatever your field gets narrower and narrower, essentially. So fewer and fewer people work interdisciplinary because the field's getting very tiny, and already the knowledge in tiny fields is really large. Yeah? So most researchers are so over-specialized. They know exactly what they can do and nothing else, essentially. And that is a huge problem in some sense. So they all just talk to their peers, yeah? So everyone is the same, right? Everyone just talks to their peers, and there's this little circle of ideas, and it never goes anywhere else, because it's kind of impossible at this point to read all the ideas that are around. And what happened, I don't have any data on that, but what happened in my experience is that there is now these little islands of groups who can talk with themselves internally, and they have kind of their own language, and then there's another island somewhere else, and they're essentially doing the same, but the language is so different that they can't communicate. And there's just plenty of islands everywhere. And yeah, part of the problem here is, I don't know whether this is just a natural thing that is supposed to happen, but part of the problem is that there are more and more papers, there are more and more researchers, the number of papers grows. Yeah. Again, from my own experience, when I just look at myself and look at the people my age and around me, and like what it was 10 years ago, people publish more papers, right? They're not just more people, but also people publish more papers. It's literally this publish or perish kind of really hard pressure on people, I guess. And yeah, it's ridiculous. And this is really where AI could be kind of a game changer. I don't know yet, we'll see, but it's kind of what it is designed for, right? AI can just read everything if you want, right? So that it's a large language model, right? It kind of can read all the papers. So that's actually a good idea for using it as a tool to essentially, if you just do it yourself, well, in a global scale, to hopefully eventually connect those little islands again, and maybe more for yourself. Maybe it points you to something that you wouldn't have touched because it kind of sounds different, right? Maybe you work in something very algebra, and actually you need an idea which is very absolutely classical in analysis, but you wouldn't touch it because you're very algebra or something like that. But it recommends a paper. You have a look and you realize, oh, it's actually exactly what I do. And this I think could be really useful. Hopefully it will be, but we don't know. But this is essentially what LLMs are built for, large language models are built for, right? So hopefully this works. Let me kind of briefly explain that AI has read a lot. So essentially, the point is the jargon AI finds results related to what you do that you would never looked at. That's what I said, right? We have all these little islands. Maybe in another island they almost do the same, but they speak a different language, so you can't really communicate with them. And then there's AI, which is really good for translation. And this attention mechanism that underpins most elements that are in use today is literally built for finding connections. So I really like this picture. I have a little bit of a bigger one here. So essentially, this is an attention matrix. Can we open that in a new tab and make it bigger? We'll see. Yeah, not too bad. So you can see it here. So it's essentially a translation thing. And this is the matrix as a heat plot, right? Or big numbers correspond to white and small numbers correspond to black. And in traditional translation, you translate just word by word. And that works really well if this picture would be a diagonal. But here in this English versus French, you'll see that these three words, European Economic Area, are in French literally the other way around. And you can see that here in the matrix. And attention will pick that up because it kind of has built in or is trained on to recognize what words are related, how things are related. And this is just a very tiny picture of what an attention thing can do, right? It has it's trained on, it's trained to connect, to find things that are connected using essentially this type of pairing matrix. Here's the same, the words are slightly twisted, and the pairing matrix will pick that up. Essentially, that's what it is, and you can find the connection between things. So this is literally what a large language model is built for. Yeah, it literally knows all the literature if you want, whatever that means. It doesn't really know the literature, but it's kind of trained on a lot of text, so it can actually find relations that you would have never found yourself. It's literally this idea, or at least the idea works very well for me, of those different research islands that kind of do the same but speak a different language, so you need a translator to translate between them. So this is literally their bread and butter, if you want. Yeah. So this is something, well, it should be able to do it well, and it kind of can do it really well. So there are studies on this. Let me at least let me just pull it up. So essentially, so it's essentially what happens. The only really study I found is this one, the emergence of LLMs as a tool in literature reviews. So literature reviews are not a big thing in maths right now, but I have seen some literature review papers. Usually in mathematics you don't have that, but in other sciences you have that all over the place. You don't write a real paper, if you want, whatever that is, but you write a review paper. Yeah? So you're reviewing whatever an experiment someone else did somewhere. Again, in mathematics, that's not a big thing yet, but there are some review papers, actually. Kind of interesting. So maybe there will be a trend that in mathematics eventually we'll have more and more review papers as well. Probably it's useful because there are so many papers. So they might make this point here that the number, probably it's in the introduction, the number of reviews here in the first paragraph, the number of reviews grows a lot, actually. So there are a lot of reviews. And essentially they want to make the point that a lot of these reviews look like the AI have written, essentially. And yeah, so that's what AI should actually be doing, right? It can review papers. So they have a lot of nice little plots. Let's see. Oh, come on. Paper is so long. This is, by the way, the number of papers published, and it's per country. And it's essentially what you would expect, I guess. And here's the picture of the United States. And again, it's probably what you would expect. But anyway, that's not what we're looking at. So this one. Types of review are automated, right? So usually searching for publications, data extraction, title and abstract screening, things like that, right? So systematic review, because it's really good to make these connections, right? Searching for publications. And they also have an evaluation of the different things you can do. And it turns out searching for publications, I don't know why, turned out to be not that great in this evaluation, but everything else was pretty good. I would still make the point that searching for publications is actually worthwhile. Searching in the way that I'm going to explain on the next slide. But anyway, keep in mind it's not a magic understanding machine, right? It's very good at filtering and rephrasing, but you still need to do. You are still the authority. You are still the supervisor, right? It's like the student, the very eager student that could make a mistake, and you are still the supervisor. But most reviews at this point are actually LLM assisted, yeah, and this trend will just grow because, again, the problem is too many papers. Nobody can read too many papers, so it's probably better. Nobody can read all papers, so it's probably better to have some reviews of some important works, and this is just what LLMs will be used for. So there's probably no way to stop that, right? So whether it's an LLM or something else in the future, we don't know. We'll see, but there's probably no way to stop that. So eventually, all literature there will be reviews of literature from AI. And there's of course some danger involved. There's AI slop, can happen. So hopefully we do that in some nice way. So in principle, I'm very positive what AI can do for you, but of course there are some dangers. The obvious one, I have it here again. Please double check everything, but it's still very useful. Let me give you a toy example from my own reading, research, whatever. So I actually wrote a paper about it quite recently. And one kind of the key idea in that paper was AI. AI didn't had the key idea, right? We had the key idea as a team of authors, but AI pointed to the right paper, which is kind of an interesting thing, essentially. So the fact here is it was a paper about links, so here's a link. And essentially I asked questions, I wanted questions about the link. So I Googled that, right? So whatever, alternating link, blah, 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 and I didn't find anything. And eventually I asked AI, and AI made this point, which is exactly this idea of little islands and translation between them, that an alternating link is actually just a planar graph, right? So essentially you just forget that you have a crossing type thing. And since it's alternating, so you go over, under, whatever, this data is essentially equivalent. You just need to choose for one of them whether you go over or under. So an alternating link is essentially the same as a planar graph, yeah? And I knew that, but I somehow forgot it. Something that didn't came up to my mind, and I was always Googling or always trying to find alternating link and then whatever I wanted to know about an alternating link. And AI was smart enough to that's what it's good at, right? So piecing together things that are kind of related in some nice matrix. AI was smart enough to say, okay, your question is actually a question about planar graphs, which I could have figured out myself, but I didn't. It's a question about planar graphs, and it pointed me to a paper which did exactly what I needed. Yeah, and I probably would have never picked up that paper itself because I was trying to look for alternating links, right? Not planar graphs. And yeah, that was just really, really, really cool, really efficient, and kind of a key example how AI can be used, right? It's a research level question. And of course I did everything in the end, but it pointed me to the right thing. And this is like this analogy I always have in mind, that if you have 10 people working for 1 hour and you have one person working for 10 hours, that's not equivalent. Sometimes these little things where it just points you toward the right thing is absolutely great. And you might argue, well, I could have just talked to my co-authors. Sure, that could have happened as well. Colleagues, please talk to your colleagues, but sometimes it's just more efficient at 2 a.m. in the morning to ask AI instead of calling your colleague or something, right? So sometimes you just do that, you can just do it, and it happens from time to time that it just points out the right thing. It doesn't know what it's doing, but it points out the right thing, and then you can just pick it up from there. And I think this is a really cool example of how things work, right? So my summary is, and in this picture I went, instead of with islands, I went with right bread. So a lot of research fields are actually very similar. In mathematics you have this, in mathematics it's in particularly bad because mathematics is a science of proof and there are not many things you can prove. So a lot of research fields look very different but do exactly the same thing, just in a different language. Happens all the time. Yeah, almost the same, but not quite. Right? So here, this white bread is not quite the same as this white bread, I guess. There are some little spots here, they're not here, whatever, but they're almost the same. Still, they can't talk with one another. They have different language. They're almost doing the same, and this is what AI can really do very well, right? It can suggest related work outside of your field, right? It suggests planar graphs instead of links. Pretty good. So that's something you can actually try out yourself. Maybe you have a question in field X, but maybe there's an answer in field Y that you would never ever look at. AI is fantastic at that. You still need to do the last check, right? It's still you that pieces together the ideas and whatever, but it's really useful. So you're still in charge of the big picture. So treat it as a kind of a noisy assistant. Anyway, I hope you enjoyed this video, and I also hope to see you next time.